everyone, I am Mohammed Yusuf, a strong and brave-minded person. I am currently pursuing my UG BECS in National College of Technology. Hi everyone, I am Swami, disciplined and dignified person. I am currently pursuing my BE Computer Science Engineering in National College of Technology.
Hello everyone, my name is Lokesh Babu. I am currently studying 4th year Computer Science and Engineering in SNS College of Technology. Today I am going to explain my project. Today we are going to demonstrate our project called Smart Helmet, which is designed to improve road safety using embedded system and sensors. So the main idea behind this project comes from a very common real world problem. Many accidents happen because rider either don't wear helmet or rider under the influence of alcohol. Even worse, when accidents happen, there is often a delay in getting medical help. So we thought of creation a system that only protects the rider but also actively ensures safety rules are followed. Now let's look at our prototype.
First, we have this IR sensor. This sensor is responsible for detecting whether the helmet is being worn or not. In real helmet setup, this should be placed inside the helmet padding. Where the rider wears the helmet, sensor detects it only, then the system allows further operation. Next, we have the MQ3 alcohol sensor. This sensor detects alcohol from the rider's breath. If alcohol is detected above a certain limit, the system prevents the vehicle from starting. This helps in avoid drunken driving. Now we move to accident detection. We are using a vibration sensor and MPU 6050 module. The vibration sensor detects sudden shock while the MPU 6050 help in detecting abnormal movement like a fall or crash. All these sensors are connected to the ESP32, which processes the data and takes decision based on the condition. One important thing to note is that all these sensors work together as a system rather than individually. The ESP32 continuously read data from each sensor and compare it with predefined condition. For example, MQ3 sensor does not instantly give accurate readings. It requires a small warm-up time and its sensitivity can be adjusted. Similarly, the MPU 6050 provides continuous motion data, which helps in identifying whether the movement is normal or abnormal. The vibration sensor alone might detect small shocks like road bumps, but when combined with MPU 6050 data, the system can better distinguish between normal riding conditions and actual accidents. So combining multiple sensors improve accuracy and reduces false detections.
Now let's understand the working of the system. When the system is powered on, it first checks whether the helmet is worn using the IR sensor. If the helmet is not detected, the system blocks operation. If the helmet is worn, it then checks for alcohol. If alcohol is detected, again the system stops operation. Only when both conditions are satisfied, the system allows normal operation. During riding, the system continuously monitors motion using the vibration sensor and the MPU 6050. If a sudden impact or abnormal movement is detected, it identifies it as an accident. In a real world implementation, this can be connected to GPS and GSM modules to send emergency alerts to family members or ambulance services. So overall, the system works in three stages: prevention, monitoring, and emergency response. This project this project helps in reducing accidents, enforcing safety rules, and improving emergency response time. Now we will demonstrate the working of the system in real time. First, when the helmet is not worn, the IR sensor does not detect any object. In this condition, the system will not allow operation. Now, when we place our hand near the sensor, it simulates wearing the helmet. As you can see, the system now detects it. Next, we test the alcohol sensor. When we expose it to alcohol or breath, the sensor detects it and the system identifies it as an unsafe condition. Now for accident detection, when we tap or shake the setup, The vibration sensor and MPU 6050 detects sudden movement. This simulates an accident condition.
This is the ESP32 sensor, which acts as a microcontroller unit, which is the brain of our project. Then this used to calculate and send and receive the signal to our modules. Then this is the IR sensor, which used to detect the user wears helmet or not. Then the signal sends again to the microcontroller unit. Then the first step completes. Second step comes to gas detection sensor, which we use as an alcohol detection sensor. It detects the user whether consumes alcohol or not. If not, then the green signal sends to ESP32, else red signal sends to ESP32. When green signal sends to ESP32, the ESP32 sends signal to relay module, which connected to the bytes, then ignites the process. Else the alcohol sensor detects the consumer consumes alcohol. The red signal sends, then the ignition process didn't initiate. Then any accident detected, the MPU 6050 and vibration sensor used to detect whether the user crashes or sudden impact detected. From the sudden or anomaly signals catch to MPU 6050, which is also known as actuators, combine of gyroscope and accelerometer. With the help of two 6-axis, with the use of 6-axis units, the algorithm finds whether the user crashes or sudden heavy impact are detected. Hence, double ensure the vibration sensor used when the threshold value reaches high, then the signal sent to ESP32, which confirms there is an heavy vibration and an anomaly signals received from the MPU 6050.
This project shows how simple embedded system can be useful to solve real life problems efficiently. Even though this is a prototype, it can be extended into a real world product by integrating it directly into helmets and vehicles. By enforcing safety rules and reducing response time during accident, this system has the potential to save many lives in the future. Thank you.